our first step is to find the radius of that circle. So what we have here, if I scroll down, is we have a chord that's 48 feet. So I'm going to cut it into 24 and 24. And this piece here is the 18. So what we're going to be able to find from that is this distance, which we'll call x. How do we find x? Perfect. 24 times 24 equals 18 times x. So 24 times 24 divided by 18 is 32. Is that right? So x is 32. What is the diameter of that circle? Where did I get 50 feet from? 32 plus 18 is 50. So the radius then is 25, half of that. So we know our radius is 25. What does that tell us for what we have to add on to the bottom of this? You got to add 7 feet. Now from that is the center of our circle here. By the way, from here out is still how far? That's still 36 feet, by the way. From the center of our circle out to this point is our radius of 25 feet. Now, what makes this different from the ones we've covered? We know there's a right angle down here. Before, though, because this was always tangent, we knew there was a right angle up here. On this one, it is not tangent. So we know that this is an obtuse angle. How do we know it's an obtuse angle? Yeah, it's got to be bigger than 90 because a tangent would be 90 degrees. To be less than tangent, it has to be bigger than 90 degrees. So we know it's an obtuse angle. What other angle can we find on that shape there? And by that shape there, I'm talking about this bigger shape here. We can find this here. Inverse tangent of 3 over 12 is what? Zero 4. So we add that. This is 90 degrees here, so we add that up. We get 104.04 degrees for that whole angle. Yep. Now is where things change drastically. Because we don't know anything about this angle, we can't figure out anything about this angle quite yet. What we're going to do is we're going to cut this across here. And what we have there is a right triangle. What's this side of it? 15, the 7 plus the 8. What's down here? 36. So this angle is the inverse tangent of 15 over 36. So 22.62 degrees. It's that angle. We can also find this side over here. How are we going to find this side? You got it. Square root of 36 squared plus 15 squared. That's 39 feet across there. Now, what's this angle here have to be? Where'd the 67.38 come from? Yeah, we had 90 here, so it's 90 minus 22.62 gives us that. So that means this angle up here has to be 104.04 minus the 67.38. 36.66 degrees. Now, we have in this triangle, we have 36 points, what was it, 66? We have 39 feet, and we have 25 feet, the radius of our circle. We can find our missing pieces. First thing we're going to find is this angle here. we already know it's obtuse. So we're going to start out with what? Law of sines. 25 over 36, sine of 36.66 degrees equals over sine of theta, 39 over sine of theta. So we will cross multiply and divide. And then we'll do our inverse sine. So sine of 36.66 times 39 divided by 25. 0.93, then we do an inverse sine. Gives us 68, and we subtract that from 180. You get that angle is 111.34. Then we, of course, do 180 minus that and minus the 36.66 to give us that this down here is 32 degrees. Now, since we're going to do perimeter eventually, let's go ahead and find this length out here. How do we find that length? 25 over sine of 36.66 degrees equals x over sine of 32 degrees. Very good. 25 times sine of 32, close parentheses, divided by sine 36.66. 22.19 feet. So I'm going to write that in up here on my figure. Because I'm going to need that later. So back here up on this picture, this is 32 feet or 32 degrees. What does that tell me about this angle right here? Yes. 180 minus those two angles is 125.38. Now we have everything we need to know to find the area of this. We're going to call this piece 1. How do I find that area? It'll be 36 by 15, right? That's just this triangle. So piece 1, 36 by 15, what do we have to do that? Divide by 2 because it is a triangle. What is that, 270? Piece 2, I'm going to use this side, and that angle. This goes back to what we learned a couple weeks ago. That is going to be 25 times 39 times the sine of 32 degrees, 2. 258.34 square feet. So there's two pieces. Our third piece is this sector of a circle over here at 125.38 degrees. So we find the area of the whole circle. Pi times 25 squared, because that's a radius, times, what was that again, 125.38 over 360. Yes, sir. All done? Thank you. So we get for that piece 683.50. So we add those three up. We get 1,211.84 square feet. Does that look right? So far? What do we still need to do? 7 by 36 is going to be this piece. You're right. We got to subtract that out. No, it can't go all the way over because that other part isn't all rectangle. I'll show you here in just a second. So 7 times 36 is 252. Then over here we got to subtract this piece, 24, right? 7 by 24 divided by 2. It is the radius, but that doesn't go all the way out to the radius. It goes out to the edge of that original arc. And that only goes out to here, which is half of the 48. So 7 by 24 over 2. What is that, 84? Of course, these are square feet. And then we need to know this angle. Why do we need to know that angle? Well, because that'll be this angle down here. Yeah. So that is the inverse tangent of 7 over 24, opposite over adjacent. (16.26 degrees). So I'm just going to put that down here. So that sector that we got to subtract out is pi times 25 squared times 16.26 over 360. (88.64). So let's just, I'm going to cheat and punch this in. So 1211.84 minus 252 minus 84 minus 88.64. We get 787.2 square feet. That is our area. How about a perimeter? Mostly, we have that this down here is 48 plus 12 is 60 feet, right? Plus we have the 8 feet on the side, plus 22.19. And you're absolutely right. We need that arc of the circle. That arc of the circle, we need this angle from here to here. It is not the 125.38. We have to subtract the 16.26. So that is 109.12 degrees. Is that arc? So that arc is going to be pi times diameter. So 3.14 times 50 times, what did I say that was? 109.12 over 360. $47.59. So we add that all up. We get (137.78 feet is our perimeter. What do you think? Not so bad? Ready for a quiz on it? Not really? Let's let you guys try one here. Now I'm going to try to get numbers that work out nice for you here. I'll be nice to you. That don't work. So I've got, that was cold, man. Find the area and perimeter of this. Let's see if we started out right here. Finding our radius. We've got 36, 36, and 24. How do we find x? Thirty-six times 36 equals 24 times x, which makes x equal 54. Okay, so that means our diameter was 78. So we have a radius of 39 feet. Does that look right? That's what we found for radius? Okay. So that means 39 feet, which means we have to add how much onto the bottom of this? To get from 24 to 39, we have to add 15 feet. This is going to be 39 feet now. This is a right angle. Of course, your next step is going to be to find that angle. That angle and that angle together, of course. And go from there. I'll give you guys some more time to keep working. What'd you get for this angle right here? Inverse tangent of 2 over 12, right? 9.46, so yes, this is 99.46. So then you're going to cut it from here to there, right? How do you find this angle? 54. Because it's still 36 from here to here and 18 out. That length from the center out has not changed, right? This length got bigger, but that length didn't change. So this is the inverse tangent of 25 divided by 54. No, because, well, sure it did. It moved out to be 39, but then that took it out of the 18. This point from here to out there has not changed because this point didn't move. So that angle gets to be 24.84 degrees. This length here then is the square root of 54 squared plus 25 squared. 59.51. Okay, I'll let you guys go from there and see how you do. Because from here out, this was 36 and this is 18. That adds up to 54. Well, the distance from here to here hasn't changed because we just went straight down here. The center is still below the center, so it's still 54 all the way out. And that is a big mistake. A lot of people want to say, well, now it's 39, so you got to add 3 feet to it. But because this is straight here, it doesn't change. We've got this angle up here. It's going to be 65.16 degrees. Makes this angle over here 34.30 degrees, right? So we know this one up here is obtuse. Let's find that angle. We've got 39 over the sine of 34.30 equals 59.51 over the sine of that angle. Now we know this, we're going to get the sine, so we have to do an inverse sine, and we also know it's obtuse. So we're going to have to do a supplement. The sine of 34.3 times 59.51 divided by 39 gives us, the sine is 0.8599. We inverse sine to get 59.30. We find the supplement, which is going to be 120.70. So this angle right here is 120.70 degrees. Making this one over here, what is that, 25 degrees exactly? Right there? Does that look right? Okay. Maybe 25.01 depending on your rounding. Yeah, close enough. Okay, that works. So then this angle over here is of course 180 minus the 25 and minus the 24.84, giving us 130.16 degrees. So now we are prepared to find 1, 2, 3 areas. Area 1, 54 times 25, divided by 2, which is going to give us, what is that, 729, something like that? No, it's not. 720. Ah, heck, we'll just do it. 675. There we go. Yeah, 675 square feet. So that is area 1. Area 2 is 39 times 59.51. Times the sine of the 25 degrees over 2. I'm going to rewrite that so maybe it's readable. $490.43 square feet. And area 3 is that sector of that circle. So we start out with pi times 39 squared times, what's that angle? 130.16 over 360. $1,726.77. So we add those up. You got what, 2892.2? Does that look right? So then what do we still have to do to that? We have to subtract. This here is 54 by 15. Which is what? 8,100? 810? So minus 810 square feet. Over here, we've got a triangle that's 36 by 15. So that's 36 by 15 divided by 2, which is what, 280? 270. What did you do for that one, Ryan? Oh, it's got to be 36, because this up here is 36. Oh, gotcha. Yeah, that's not going to work. We've got to have this angle right here is what we need. So we need this angle, which will be the inverse tangent of 15 over 36. Yes, sir. Yep. Yep. So that's 22.62 degrees. So we've got to subtract out that arc of 22.62. So that arc is going to be pi times the 39 squared, that's the whole circle, times that 22.62 over 360. 300.09 square feet. So if we subtract those out, and yes, I'm going to be lazy, 2892.2 minus 810 minus 270 minus 300.09. 151211 square feet. That's our area. Anybody come up with that? Or close to it? Within 10 of it? Anybody confident they would have got there if I'd given you more time? Cool. Anybody want to go home and cry? Yeah. That's the most common mistake. And what happens, like you said, well, what doesn't the radius push out? And you're right. If I extended this down from here to here is 39, but that just comes out of the 18. That's just down to 15 feet now. Since this goes straight down, it doesn't move out. The distance from center to outside edge doesn't change. Yes. Yeah. I had, was it 15? Okay, so my one disappeared on me. That is definitely close enough. There we go. Well, then I think it is time.